Hello and welcome to my channel. If you've been here before, welcome back. My name is Alfonso Peluso and I'm a Studio Associate Professor in the College of Architecture at IIT, the home of the legendary Mies van der Rohe, and let's not forget we have the campus center designed by the famous Dutch architect Rem Koolhaas. Today we're going to be looking at Kangaroo, which is a plugin for Grasshopper. So I'll go over to a file that I have here, and you see this stretched form spanning between two buildings, and I can do a number of things with this. I can adjust the load that's being applied, so you see that in the Z direction. And we're going to look at doing that. I can also move around some of these anchor points. So I have a couple points here in the corners that I can move those around freely. So we'll look at doing that as well. There's also a point in the center. We can move that around. So I hope everyone's day, semester, whatever's going on is going well. I'm here in Chicago and it's a rainy morning. It's a rainy fall morning. It's kind of nice. We had a little snow already back in October, and this video is being filmed or recorded November 21st, so we've had a couple snows already. So if you haven't subscribed to my YouTube channel, I encourage you to do that. Go ahead and click on subscribe and then click on the little bell so you get all the notifications of when my videos have come out. Also, connect with me on Instagram. My Instagram account is my first name, Alfonso _ my last name, Peluso. See what I'm up to, see what videos I'm working on, see what my students at IIT and the College of Architecture are up to. Okay, so let's get into the topic for today, which is using Kangaroo 3D, which is a plugin for Grasshopper for computational form finding. So I'm at kangaroo3d.com. And this is a website that was created by Daniel Piker. Daniel Piker is actually the creator of the plugin Kangaroo 3D. And simple website here. He has some videos. He has a blog that you can look at. This information, some of it is fairly old, but still really relevant. So I encourage you to go look at that. And there is a link for download. And when you click on the link for download, that's going to bring you to the Food for Rhino page where you can get most plugins for Grasshopper. Okay, let's start off by just talking a little bit about form finding. And I've searched Antoni Gaudí form finding. So Antoni Gaudí, he's the godfather of form finding. And what you're going to see in some of these images, for instance, this one is a hanging chain or hanging rope model in some cases. So there's chains or ropes that are hung upside down, and you see these bags of sand, I'm guessing, that are holding those chains in place, and it's creating these catenary arches. So this is a model of the Sagrada Familia in Spain that may be completed at this point. But the idea is that you turn this model 180 degrees, and it's a pure optimized form that's entirely in compression. I'm kind of proud because when you do Antoni Gaudí form finding, you see some of the work that I was doing with my students in a studio a while back, and these are hanging paper clips actually. So you see this is pretty similar to something we're going to make today, where something is pinned in four corners, and then when you flip it right side up in this image, it's a form that's purely in compression. Okay, who else do we need to talk about for form finding? So after Antoni Gaudí, we have Felix Candela, whose shell structures are quite amazing. And when we look at his very thin shell structures, we can see some beautiful forms. And now there's a resurgence in these types of forms. So you're starting to see some new images show up in here, like Zaha Hadid. And this resurgence has a lot to do with, the computer and with Grasshopper. And I love this image. I always show this to my students. Excuse me. This is how Antoni Antoni Gaudí did his structural testing before you could, use computers. And I think this is a great image. Just get as many people on there as you can before this thing fails. After Felix Candela, Heinz Eisler is another important figure. He's a Swiss structural engineer, and he did a lot of work like Candela with thin shells, and he did a lot of form finding models with plaster. He did some with ice, which I think are really amazing. Here are some of his plaster models that he used, and he developed this great method where he overlaid this grid, and he was able to translate the structural loads at a full scale. So going from a scale model to a full building size. And then we have Frei Otto, was the German architect, and I call him an engineer, who is most famous for his Munich Stadium in Germany, which is this tensile roof structure that's is glass and cable. So you see some images of that here, and this is similar to something we're making today in Grasshopper and Kangaroo. All right, so let's go ahead and get into this. All right, I'll switch over. Okay, a couple things that we want to be aware of in terms of making this file today. So these are the things that you're going to need for form finding. You're going to need a boundary surface. And you can jump from a boundary surface right to the boundary mesh, but we're going to start with the surface in our exercise. And so you need a boundary surface. We're going to convert that to a boundary mesh. You're going to need some anchors, or what could be called supports. You're going to need a load. And then some of the stuff below is just some fine tuning. We're going to look at how we can adjust the load strength to raise and lower the anchors. And this will not be manually by hand like you saw me do at the beginning of the video. This is going to be through number sliders. And then to move those loads around by hand, we're going to look at extracting the parameter and then internalizing the data. Okay, so let's get started with the boundary surface. So I just copy and pasting some of this text out here and putting it in a scribble so we can. I feel like staying a little organized today. I don't know why, but I just do. We'll keep it a little organized. So we're gonna make the boundary surface, and we're gonna do that by making a plane surface. Okay, so you see a little plane shows up at the origin there in the Rhino window. So we're gonna make this. Let's see. Let's try 60, and then we'll make it 60. Let's try 30. Okay, so that spans nicely between those two buildings that we'll use later on. So that's our boundary surface. Now we're going to need a boundary mesh, or not need, but we're going to convert this to a boundary mesh. So I'll make another scribble, and this will be our boundary mesh. And we're going to do that by using I can do this a couple ways. I can do a mesh surface, or I can do a mesh brep. I like mesh surface better because I can then control the U and the V count, which is really important for form finding because it rebuilds the surface and it gives it the flexibility so that it can undulate and deform. So it has a U and V count here. I'm going to start with 12, just starting with 12 because I get a number slider that's greater than 10. Okay, now you see those U and V curves. So as I go, I'm going to turn the preview off for some of these capsules so we're not viewing too much information. Okay, so we have our boundary surface check, boundary mesh check. Now we need our anchors or our supports. So we can do this in a method that I've done before. I made a Carumba 3D video. Carumba is a form finding plugin for Grasshopper as well. I should say that this Kangaroo one we're looking at right now is a physics engine, The Carumba 3D is a FEA modeler, which is a finite element analysis, which is what structural engineers use. So if you're interested in Carumba, I'll put a link to the video at the end of this. And I go through a similar process as this, where I define the anchor points using an evaluate surface, and then I project those onto the mesh. So to do that, I'm going to type in the command evaluate, and I'm going to choose evaluate surface. And the surface that we're evaluating is the plane, the boundary surface. So I'll go ahead and plug that in. I'm going to use an MD slider to define the position, and I'm going to make this rectangular, like my surface out here, kind of, just representing that visually. And I'm going to go ahead and plug this into point. So you see I get a little green point in the lower left hand corner here, and I really want that in the middle of the structure, but it's just hanging around the lower left hand corner. That's because if I go all the way to 1 to 1, it's using a unit of 1 to 1, whatever that is, if it's millimeters or inches. I want 1 to 1 to cover that entire surface. So what I need to do is right click on the surface input and choose reparameterize. Okay, so now this is pretty much representing the area of my surface. And for right now, I want to put a point in each of the 4 corners. So there's my first point. I can take this point, copy paste it. I'm going to just go clockwise with this, so I'm gonna move this straight up here, and I'll go ahead and plug that in. So there's my second point, and so on, and we'll do this until we have our 4 points. Okay, so move this one in the upper right, plug it in. Don't forget to plug it in using the shift key, and we'll copy and paste this one. This will be our last corner. Let's go ahead and move that first. If I don't move it first, sometimes I forget to move it, and I plug it in and wonder what's happening. Okay, so those are going to be our anchor points. Now, those anchor points need to be on the mesh, and at the moment they are just on the surface. So we're going to use a capsule called closest point. There is a closest points, plural, but for this particular example, we're going to use closest point, singular. So I'm going to go ahead and I'm going to plug that into point. Okay, so that's the point that it's going to find the closest point on this mesh. Now I need to gain access to the points of this boundary mesh, which I don't have just yet, because I need to gain access to those points and then plug that into this cloud, this closest point cloud. So the way that I'm going to get access to those points is I'm going to use a capsule called deconstruct mesh. And you'll see that has a vertices output, and then you see all those vertices just showed up there. Okay, so I'm going to take those and plug those into the cloud. Alright, so I'll try to keep these wires from going behind so you can see. Alright, so this closest point, basically what it does, if I use a scribble, is it projects the points from the surface. So it projects points from surface to mesh, which we need. We need that. We need these anchor points to be on the mesh. Okay, and we could even look at this just a little bit closer while we're here. So I'm going to bring out a panel where I plug these points in. Okay, so there you see some XYZ values. And if I do the same thing with the panel here, copy and paste this, plug that in. In this case, you're going to see that these points are identical because they are the exact corners, 0, 0, 0. This thing was 60 by 30, so these are the exact corner values. So in this particular case where I'm using the very corners, I actually didn't need a closest point, but I use it anyway. But any of the points that are off the corners that fall somewhere on this surface that are not exactly on one of these points, you you can see if I, if I was to zoom in here and I picked a point, say like right there where my cursor is, it's going to find that as the closest point. It has to be one of these mesh points. I can't anchor anywhere where there's not a point on the mesh. So that's pretty important to understand. Okay, so now I can, you see I have my Kangaroo tab here, and I'm going to pull down my first capsule from Kangaroo, which is an anchor, and I'm going to go ahead and plug my closest point in. Okay, so that's my anchor, and we'll deal with this target and strength later. So just using my scribble here to I'm gonna actually use. I think if you're just starting out with Kangaroo, you can highlight the Kangaroo capsules so you know which ones they are. You'll see in a moment. We're gonna have to plug them all into a solver. So that's my Kangaroo anchor. Okay, so we're doing pretty good. We have our boundary surface, our boundary mesh. We have some anchors. Now we need a load. So let's go ahead and we're going to bring down the load. Okay, and I'll copy and paste this scribble. So this is going to be Kangaroo load. Okay. All right, so now it needs some points to apply the load, and we have that through our deconstruct. So we're going to plug in our points there. And then it needs a direction for that load. So we're going to use a Z direction. And we will actually, in this case, we're gonna lift this up, so it's a positive Z. And based on the size of this, it can be a really small value. So I'm going to type in, I'll type in 2.555 for some decimal points, and I'll go ahead and plug that in. Okay, so I'm going to move some of this over, give it its own space. So there we have the load, the anchor. We're going to have to plug those in to what's called a solver. So I think I'll get started with that solver. There's one thing that's we have something missing from our list over there, and we'll get to that in a second. So under the main tab here, there's a Bouncy Solver. I kind of like that one. It's a lot of fun to play with. And so there's some goal objects. So that's what we're defining, the load and the anchor, and we're going to need a couple more are the goal objects. And I like to use a merge capsule just so I can see where these things are being plugged in instead of just using my shift key to plug them into the goal objects. So there's my load, my anchor. Excuse me. I'm also going to need a show, which will show the mesh. So that's something important that we want to see that. So this is show, and I have to plug in my boundary mesh to that capsule. So slip right through there and plug that one in. Okay, so nothing's happening yet as I decrease or increase this load. A couple more things that we need. We need a reset toggle. So we can use a Boolean toggle for that reset, and won't quite see anything happening yet. Okay, we need to plug this merge in to the goal objects, so that gets plugged in, and you saw this thing go flying up in the air. See if I don't know if we can. I don't think we're going to be able to bring it back down. Let's go ahead and Boolean toggle reset, so this thing goes flying into space there. Okay, so one thing that we are missing, okay, is we're missing some springs, some tension in this mesh. So let's get that mesh to come back down. Okay, so in our list over here, that's one thing that wasn't mentioned. I left that out. We need that. We need our springs, and I'm going to bring out a scribble. So we're going to do that. We're going to figure out how to turn all those mesh edges into springs so that this thing has some some tension. It just doesn't spring up into the air and go on forever. Okay, so we'll need our springs and a couple Grasshopper capsules. One is mesh edges, so we're gonna get our mesh edges. Okay, so I'm gonna plug my mesh capsule into the mesh edges, and then from Kangaroo, we're going to need a capsule called length line. Okay, and I'm going to plug both my interior edges and my outside edges. That's what the naked edges are, the outside edges. I'm plugging those both into line. Now I've seen my students plug one into line and one into length, and we have problems. So we want those both to go into line. So this is gonna be our Kangaroo springs, so we need those. Okay, so making sure that all these that I labeled Kangaroo, this is this other one is my Kangaroo show. It's really showing show mesh. Okay, so that's your checklist. You need these springs, the load, the show, and the anchors. Okay, I'm gonna go ahead and plug this into the merge, and it shouldn't be an issue of what order those are plugged in. We'll find out in a second. Yeah, that seems to be working. So you see that thing, that mesh bounce up and form these catenary arches between the supports. So much like the hanging chain model, this is right now it's in ideal compression. That's what we're looking at there. Okay, so that's working pretty good. Let's go ahead and adjust the load on this so we can lower that or raise that as needed. So that's working great. So let's do a few things that I mentioned here, which is a load strength, extract parameter, and internalize data. So we have those three to cover. Now, just to see this a little bit better in the viewport, let's go ahead and find out where this mesh, the output is of it. So you have I, and we don't have any output for that other than it ran once. We have V, which are the points as a list, the vertices as a list, and then we have O. Maybe O stands for output, could be. But you see it's a long list, 486 items there, and only list item 0 is the mesh. So to see that a little bit better, I'm going to bring out a panel, plug that in. So there, list item 0 is the mesh. That's what I need. So I'm going to use a list item and plug my O into the list. And this is, by default, it's a 0 list item. And I'm going to use a mesh container just to go ahead and put that in. So there's my mesh. So if I have this mesh selected, if I shift control I, that inverts my selection, selects everything else in the definition. And now I can right click in the canvas and choose preview off. So I'm looking just at that mesh. And I'm going to go a little further and give it a color display. So I'm going to use a custom preview. The custom preview has a default Pepto-Bismol pink. If I take this mesh capsule and I turn that off as well. So there you see, I don't have the lines on there. I kind of like the lines, but I'm missing those mesh lines. You can always add a color swatch. I think if you see my other videos, I do this quite a bit. So I could plug that color swatch in and I can change the color of it. Okay, so I'm going to leave that as the Pepto-Bismol pink. Alright, so now you also, if you remember in the beginning of the video, I had a point in the center, another support point that was anchoring that down. So let's go ahead and add that as well. So I just need another MD slider. So I can copy and paste this. Okay, MD slider, we had an evaluate surface and a closest point. And then we had the Kangaroo anchor. So these three capsules, evaluate surface, closest point, and Kangaroo anchor. So I can actually just take those, copy and paste them, bring them down here, and plug my point into this one instead of those others. Okay, I'm going to move this somewhere toward the middle. So here you can see where this closest point really is important, because that's my UV value my U and V value on the surface from the MD slider. And when it translates over to the mesh, it's actually 35, 15, 0. So that's an actual mesh point. So that's important. And just saying that we could probably take a better look at that. I guess it's worth looking at. Okay, so yeah, perfect. So that's the actual point on the surface, and then it's picking one of these closest points, which I guess is that one, to be on the mesh. Okay, worth looking at. Alright, so this is another anchor point. So this is going to go into our merge capsule. It's another one to go into our merge. Okay, so you see that showed up there, and I can move that around a little bit. Okay, so you see that incrementally snapping to those vertices on the mesh. All right, so we got that point. So let's look at the strength of that anchor, raising or lowering that through a number slider. So not manually in the Rhino viewport, but through a number slider. So for Kangaroo, this Kangaroo anchor, it has a strength input. And that strength input has a default value of 10,000. So this is a very high number, just making sure that it pins it down. The values don't need to be anywhere that high. So I'm going to make a number slider. I'm going to do -2 less than, so -2 less than +2. So that'll give me a number slider between -2 and 2. Okay, and I'm going to plug that into the strength. So the negative values, which I'm starting with, lift it above the form found surface, and then the positive values lower that. And let's add some decimals into that as well, so have a little bit more control over that. So now the problem going from 2 to 2 is I can't get it to actually lower all the way down on the ground. How far do I need to go for that? Not exactly sure, but I'll make the maximum. Let's try 10 and see how low that gets it. Let's try that again. So setting the max to 10, put the green check mark. So that's getting it much lower. Still not all the way down, but you get the idea. Okay, so that's the strength. Now, if I want to manually move that point, I can do that as well. I'm going to take away the strength. Okay, I'm just unplugging that. Oops. Okay, unplugging the strength, it pins it back down. So the other two topics that we needed to talk about were extract the parameter and internalize the data. Okay, so let's do those two things, extract parameter and internalize data. So the parameter that I'm extracting to begin with is I basically don't need to extract it. I could use a point container, but since I'm here, I'm going to right click on the input for target, and I'm going to extract the parameter. It just gives me a point container again. So that's all that is. It's just giving me a point container, nothing special there. The data that I want to plug into this target is this point data right here. I need that point data to go in there. So I'm going to plug this closest point into here. Okay, you see that point shows up. I'm going to right click on this and internalize the data into this container. Okay, now when I deselect it and I select it again, I get my gumball arrows to show up. And I'm guessing I need gumball on for that, maybe. I'm not sure, but gumball is on in Rhino. And now I have the X, Y, and Z axes where I can move this. So now I'm just moving it manually. Now I cannot snap it to any of the geometry. If you were wondering why I had these buildings out here, I was thinking, wow, it would be great, really great to be able to snap to that, but I can't. I can just manually move this. Okay, so let's do that one more time. Let's do that with our other anchors. So I'm going to do that up here. All right, so this time, just to show you, I can bring out a point container and plug that into the target. So I didn't have to do the extract parameter, but it was good to see that. I'm going to plug my closest point in, and then I'm going to internalize that data. Okay, go ahead and select it, and now I have those points that I can say, all right, I'm going to lift that up there. I'll leave that one down there. I'll lift this one up here. So I'm having control over those. All right, so let's move our key parameters that we're working with right now for this form finding. Let's move those all together. So here is my load. Okay, I can adjust that load. Here is here are the 4 points on the corners, so I can move those around freely. And then here is my point in the center, and I can move that around. Okay, so that's an introduction to Kangaroo form finding. I hope that you found this video helpful. If you did, go ahead and click the like button. Go ahead and leave some comments below, what you liked, what you didn't like. If you have other ways of doing this, maybe some things that I missed that would be helpful for the people in our online community, you can go ahead and leave a comment below. I'll leave some link at the end for the Carumba video if you'd like to go and do some form finding with finite element analysis. Alright, thanks for watching, and I'll see you next time.